Okay.
Okay, now what do we have here?
Huh?
We have, what's this thing called?
That's called a Wimshurst machine.
Now I've seen pictures of those in some of the really, really old stuff,
Yes.
like even with Ben Franklin era kind of stuff.
Well, it was one of the first types of machines to use to produce x-rays. The disc in those was about this big. And I've had an ambition to build one that size. But that shoot a spark about that long. This one will shoot one about an inch or two.
Now what does it do exactly, and how does it do it?
Well, generally, it's kind of complicated in a way, because static electricity originated when people rubbed their robes with what they called amber. Isn't that kind of a general organic natural resin? And our combs and things like that today.
Sure, even in the old days when they were
plastics is very much like that. Your rugs when you walk on them, you know.
Yep, that stuff when you touch something and it goes zap, that's static electricity.
Of course, in the clouds, the disturbance of the air particles, and they still don't know the whole answer to that either. But it generates tremendous electrical charges. In the beginning of this, it was discovered when amber, which is looked like a rock.
That's a resin out of a tree.
A guy by the name of Thales probably thought it was a rock. That's kind of speculation. He rubbed it on his robe to polish it, you know, say, and discovered that it would pick up stuff. That was the beginning. And in the Greek, the word for amber was electra. That's where our word electricity comes from.
Oh, fine.
At any rate, as he rubbed it then, the amber stuff was rubbing off on something else, and they would, if a Englishman had discovered electricity, we'd probably be calling it ambericity. That's just part of my own.
These little dudes down here, they're little...
These are jars. When they discovered that this stuff would jump from one thing to another, and as they experimented with what we now call metals and nonmetals, they discovered that all metals would allow this stuff to pass through it and flow through it, just like we think of water flowing through a pipe. And so in the later times, during the Dutch Holland experimenting in a town in Holland, capital, Leiden, Holland. They thought they would see if they could collect this stuff in a jar, and they put this wire down in the jar, and of course nothing happened, because they finally discovered that you had to coat the jar with metals on the inside and outside, and since the jar was made of glass, you had an insulator between the two. Then applying your sources of negative to one side and the positive to the other, they could collect that inside that jar in those metal sheets. That was a...
It's a battery.
No, it was
well,
okay. But it was a different kind of a battery. We now call it a capacitor.
Yep.
Or in those days they called it a condenser, because it was bringing all this electricity again and condensing it.
They just wanted to have more of the electricity to play with. They're not fooling me a bit.
All right.
Now this thing works by generating static.
Yes, and so it has two glass plates with metal strips on it, and as they rotate, they will accumulate natural charges that are floating around in the air. And so as one end of this gets charged positive, the other side will get charged negative. Because there's two kinds of electrical charges, just like there's two kinds of polarities in magnets. And how they discovered the idea of two kinds of electrical charges was that when they would charge an object with one pair of materials, like a comb and your hair, plastic and hair, for a long time it would be there's resins and animal fur. So they came out with plastic rods and fur from animals. Cat fur was a fly. This probably comes from a rabbit. Any kind would work.
Any kind of fur.
If you got a pet cat, you know, and you rub him real hard at night, you can see the firefly.
Yep.
So we have, for experimental purposes, science sources have learned to fabricate this stuff, collect a lot of this, and make a lot of money selling all this stuff to people. If we could do it our own, that we could collect.
So now if I look at this thing, I can think of this kind of like clouds and stuff too.
That's right.
One side being the earth and the other side being the clouds.
All right.
And
Yep.
that plate being the friction between the earth moving and the clouds not wanting to.
Well, as I said, it's still, the jury is still out totally on how lightning develops, but we know there's a lot of disturbance. There's water particles in there, and those water particles have charges on them. There's another real demonstration that you can do called a pail experiment, where you have containers of water in a couple of metal cups with little tiny holes in it. And those are connected by wires crossing each other, being real close. And so by letting the water drip out, they can collect a charge down here, and every once in a while you see a little spark jump between those wires. Let's see, what is that? Well, the water pail experiment is the way it's described. Now, I've got the diagrams of it and even tried to build one time, but at the time we were trying to make it work, the air was too humid, and you got to have extremely dry air for one of these to work. But
Yeah, I've noticed that we've had trouble here with this. When the humidity gets real high, we have to do something to dehumidify it so that it
been
will,
working real good recently, because we've had a lot of dry weather, and especially if it's dry, cold weather.
Well, let me see if I can move this camera around and get us a little different angle, and we'll see.
right.
We'll see about making some sparks. And we're ready to go.
Well, we'll crank the machine up and see if it's going to work for us today. Then we'll see if we can demonstrate how old Ben discovered a lot of the stuff. He's, oh yeah, we're going to crank up a thunderstorm here in a little bit. Now, the story is old Ben got to suspecting that lightning was the same as this charged stuff. Now, he didn't have a machine like this, but he did a lot of experimenting, and he even constructed these Leyden jars, and they could put a bunch of them together, and they could use them kind of like a battery to get a charge from it. But the difference between this and a battery is, in this, the charges are stored up on the surface of these materials. In a battery, you've got chemicals that stores it up inside in chemical bonds. Here's an analogy that I like to do. If you take a glass plate, lower it down into some water, pull it out, you can rake a little water off of the edges of that plate. Now, however, if you take a sponge and lower it down into the water and bring it out, you can squeeze out a lot of water.
A lot more water.
The sponge would be like a battery. The glass plates would be exactly like what we're going to show here. So, at any rate, old Ben flew the kite, and he demonstrated at the end of that, there's a wonder he didn't get
Get killed.
Now, so old Ben got to thinking some way or another that there's a relationship between that cloud out there and the earth, because the charges that they would build up, the earth is so big that, and we discovered that there was two kinds of electrical charges. And that was discovered by experiments with different materials charging objects, and in some cases where different materials were used, when those charged objects were exposed to each other, they would pull together. In other cases, when they would do this, particularly with two of the same kind of materials, they bring them together, they would repel. So they came up with the idea of positive using plus and minus. And so like charges, unlike charges attract, just like poles will magnetically attract. If the poles are alike,
You got the positive and the negative, and they react the same way.
So old Ben got to thinking, now if I could hook up a sharp-pointed conductor, such as you see here, since it's a metal, it's a conductor, put this up on top of a building. This guy old Ben was a pretty sharp individual. And he figured out what was going on, that the Earth's charges, if they were allowed to build up, would be strong enough to attract the charges from a cloud. So we're going to let this represent a cloud. This is going to represent a potential
lightning strike on a
lightning
building.
Rod thing. And so we'll see if we can get our thunderstorm going in here, and then we'll push this over underneath that and see if we can demonstrate something that's going on here. You'll notice we're getting a spark. You'll even notice this wire jump. Let's see what happens when we push this over under that one. Nothing happens.
All of a sudden, all these building fires that they were having before from lightning hitting the buildings stopped.
So, let's see if we can do another demonstration right quick here to see what's going on. At the end of this wire here, that's hooked into the earth, or to either terminal. We'll put a sharp-pointed conductor on that sharp point there so that it can rotate freely. And so as we
charge the air,
it's showing us now what's going on. Now, I don't know whether old Ben did something like this or not, but it sure shows. Here's the whole explanation. These like charges, as they are repelling each other, if they come to the end of a sharp point, they get ejected.
they dissipate.
Now, if we want to collect them, all we've got to do is put a round ball in there and increase the surface, and we can have, in essence, a very crude form of a capacitor. And the bigger these are, the more you can store up, the bigger spark you'll get. So that was the beginning of the experiments that were done, giving us the basis of our electronics. This is the basics.
But what I love about this part of it is the fact that it's not only electronics, it's the static electricity, but it's also how it works with our world. It's the weather.
Absolutely.
And it relates to so many different things.
There's another interesting thing we could do here if you want to see the attempt that these Dutchmen did to try to see if they could collect this in some way or another. They connected this up eventually when they made this experiment that I was referring to, this jar here. When they realized that metals had a lot to do with all of this kind of stuff, they coated the inside of a jar with a metal. They made a connection to it through a flexible metal thing that would go down there and touch that inner surface. And then, I haven't got it hooked up yet.
We've got to charge it first.
Well, I've got to connect up the outside metal here. I've got to connect it to the other side of the machine. In other words, every source of electricity has got to have, you notice a little spark jump there even then, every source has got to have a negative and a side, just like a battery.
Yep.
This will be one side, and it doesn't make any difference for a thing here which way we're polarizing it, because in either one, it'll work. Let's see if we can show evidence now that we're going to put electricity in that jar. And so you see a little spark jumping there. I don't know.
Yep, I can see it. We'll be
Now then, right quick.
Yes, I saw.
You see we can get it back. We can get a sizable amount of juice from that.
The more you put in, and over a slow time, the faster it comes out till it gets completely loaded, huh? Yes, indeed. You can see why they would like to play with those things. Whoa!
And it's kind of neat what you can do here. Demonstrate a lot of this. You'll notice everything is terminated on a ball. And so, you even got there. That's what these are.
Now we've got
Now,
this
let's
thing.
just see how if it'll. It holds it pretty good.
Now, just out of curiosity and just for fun, and so people will know, how much voltage do you think that's doing when it jumps across after it's been charged?
700,000 volts probably. Static electricity, you can get a whale of a voltage. I've never done there's a chart that you can look up to see how much voltage you can get. And this is all just about to get there. You got probably about 10,000 volts between a gap here of a fraction of an inch or near an inch.
And then the farther
And
away
so
they get,
you just multiply it out, you probably get 100,000 volts at least. I'd have to look up the details of it because it's a hard thing to calculate because you got to talk about whether you're getting the voltage between sharp points or ones with the ball. Because with the ball, it'll let it build up.
to a
And this is what's happening in our lightning arrestor. The sharp point keeps dissipating it so that it can't build up. It's just like a relief valve in an air tank. To keep it from blowing up, they got a spring that'll open in, and or a steam boiler or anything like that. They got a pop-off valve.
your car radiator.
Yeah.
That's,
And so you can use a lot of the principles of hydraulic pressure or air pressure, water lines representing, you might say, electrical lines and electrical forces that are at work in a circuit.
so there's a lot of almost fluid dynamics to
Yes.
electricity. Well, I'm going to stop this segment right now, and we'll go on to the next section here.
Okay.
There wasn't any more email on there, so.